My purpose in designing this particular circuit was to give my dog a chance to behave well, and instead of scratching at the door or barking to come in, we would know that he's ready to come in by seeing a light flash or a bell ring. An interesting thing about the circuit is that it's very adaptable. If you like hearing a bell, you could adapt a solenoid to fire and make bells ring. If you like flashing lights, you can have flashing lights. You could have a buzzer, any kind of sound out of a speaker. The IC that I used is very versatile. A key component of my circuit is the 555 timer. This is a small chip with 8 pins, 4 on one side, 4 on the other side, that has many components within it, and so it reduces the number of parts I need to use and the space it takes on my board. A key component of my circuit is the 555 timer. You'll see here that on the top left-hand side is a schematic of what the inside of a 555 looks like. These are all the components that go together in that small chip to help make my circuit function. On the right-hand side, down below, is a diagram that you would most often see in a schematic diagram that helps you put the circuit together. If you'd notice, the center of the right-hand side is the output. That's where the LED belongs. And then on the left, number 4, is where the switch would be. In addition to the 555 timer, you would also need 2 5K ohm resistors, 1 10K ohm resistor, 1 50 microfarad capacitor, 1.01 microfarad capacitor, a yellow LED, a 9-volt battery with hookups, a standard perf board, does not need to be very big, a few jump wires, and some standard soldering supplies. You see here that we have a standard RC circuit. We have some capacitors, we have some resistors. The capacitor that you see at the top of the diagram on the right, the 0.01 microfarad capacitor, is an optional one. If you don't have one, you don't have to use it, but it does add stability to the circuit. You see on the left the RB and the RA. Those are used together when the circuit is high, and RB is used alone when the circuit is low. As I soldered the circuit together, I noticed that the 555 chip did not solder as well as the other pieces. For whatever reason, it wasn't absorbing the thermal energy as well, and I was afraid to leave my iron on it too long for risk of damaging the chip. So, if you have an old chip laying around, that might be a good thing to practice on before putting it onto the board. Here you see the completed circuit. The timing is adjusted by the capacitor and by the resistors. If you wanted to change the timing on your own circuit, you can do that by using the equations at the bottom of the screen. Thank you for viewing my presentation. Here you see the completed circuit.